Throughout the course of history, there have been periods when mankind made rapid advances. And then there are those other, much more numerous times that remain rather unnoticed as transitory periods. Now, at the dawn of the third millennium, how will this age be judged by posterity? And more importantly, what form will that posterity take? And what kind of judgment will it be capable of? For soon, much sooner than we anticipate, mankind as we currently know it might radically change.
Burn, baby, burn!
Something new is emerging. While people have talked about global peace, the end of history, and the disappearance of ideologies, an army of scientists around the world has continued working in their laboratories. The impact of this work is now slowly surfacing. Technology is about to take over the torch of history and will guide us to a new era. The disparate activities of scientists in the fields of genetics, robotics, artificial intelligence, bionics, and nanotechnology seem to be converging towards one goal: to transcend human limits. It will lead us inexorably towards a transhuman age, an age when more evolved species will leave mankind behind as a fossil in history.
We are shifting to a transhuman base. We've come out of a humanist time, and now we're redefining what it is to be human.
Whether we like it or not, we're becoming cyborgs. We're becoming transhumans.
We have the opportunity now to try to do things better than nature has done.
Why not have a stronger arm than we have? Why not be able to run faster? Why not be able to have tougher skins?
If you're going to replace your eye for vision, why limit it to visual? Why not give it the kind of vision a bat has? Give it ultrasound.
Could you imagine a Versace body design? Can you imagine a Terry Mugler body design? These individuals, the late Versace was an incredible designer. What if he was a transhuman? What if he was an artist who really wanted to combine art and science? I bet his designs for a future body would be astounding.
We really, really do want to violate human limits now, and we're getting closer and closer to the ability to do it. It's what we want.
And here we are in the brain research laboratory. Yeah, here's the brain when it was stored.
Dr. Robert White is a neurosurgeon at the Cleveland Medical Hospital in Ohio.
Now here are some pictures.
In 1963, he performed the first experiment to keep a brain alive outside the body.
That's the human skull here. That's not real. This is a gorilla. See here, when you take the brain out and isolate it, you can take all that if you want, and you keep it alive and live forever. See, this is a human brain actually, and it is fixed, so no one needs to worry about it being alive. There have been many attempts throughout the world, particularly in the old Soviet Union, to take the brain out of an animal, they like the dog for example, and keep it alive with machinery. Now you can do that with the heart, the kidney, the liver, the lung, all the other body organs, solid organs. But nobody had ever been able to do it with the brain. And part of the reason is we must remember the brain is very delicate when it comes to its blood supply. And so when we finally did it and found that this brain of a highly developed animal had brain waves, had biochemistry, was functioning just as it would. Now we couldn't talk to it, we could send it electrical signals, we could show that it could actually hear and so forth, but we didn't know whether it was processing the information. But the point of it all is that that moment in time also said to us, if you can do it for the animal brain, you could do it for the human brain. This incredibly brilliant scientist, Stephen Hawking, who's an astrophysicist actually, he is now in a wheelchair and literally speaks via a computer. And some people, perhaps unkindly, have described this wonderful man as sort of a head on a computer, basically. But he would be somebody who potentially could survive his diseased body through a total body transplant.
To prove that the brain was in fact functioning normally while in this state, Dr. White needed to undertake a second experiment, during which he succeeded in transplanting the head of a monkey onto the body of another. The creature survived for 7 days before the body rejected the head.
In the monkey experiments, these animals are as much a monkey as they were when they were in their own original body. So I would presume, and I'd go beyond that, I would be assured that the monkey personality is retained. So consciousness can be transplanted. Obviously, personality, if you want to speak of the monkey having personality, can be transferred. And so you might ask, where did this bring us as far as the human spirit or soul goes? And I guess you could argue it can be transplanted.
We are now becoming the objects of conscious design. And the implications of that are just enormous, because until now, we've been reshaping the world around us. And we can see how dramatically it's been changing. I mean, we've really reshaped the landscape, and we've built a society and altered society and changed everything that's external to us. But somehow we imagined that we were going to remain the same, that we ourselves were not going to be caught up in this process. And that's not, in fact, true. We are going to remake ourselves. And it's very difficult to deal with, because it will rip free all of the anchors that have until now told us who we are as human beings.
We're at the end of a definition of what a normal human being is.
Every living thing is defined by its DNA code. The DNA is a long string consisting of 4 different molecules called A, T, C, and G, found in all living cells. So it is, in essence, a digital barcode that defines us as humans, just as it defines every other life form on this planet. Only the variety of combinations of these 4 elements makes us differ from one another. The Human Genome Project was started in 1990 as the largest technological enterprise ever, with a budget far outstripping that of the race to the moon, and involving hundreds of laboratories around the world, all with one main goal.
Fundamentally, it was about determining the complete sequence of the human genome, the 3 billion letters that make up our genetic blueprint. And we know we have the code before us, and it's truly remarkable. It is a digital code, and buried within that code is information about what are all the genes necessary for making a human brain, and all the genes necessary for making a human liver, or the heart, or any part of the human body. And now the fun stuff begins, because we get to start to crack that code, having the order of the letters in front of us. But fundamentally, it is very much a digital code.
The secret of life itself, the DNA molecule, a genetic discovery that could give man the ability to create life to specifications. With it comes the power to change evolution itself. Never have we had such opportunity, or such awesome responsibility.
Change DNA structure in the lab is fairly straightforward and it's fairly simple. You can study a piece of DNA to unravel its function, you modify the composition, and you see what the effect is on function. That's daily routine in a lab that has this technology. Going from the lab to the person to therapy, in theory, is the same thing and is as simple. In practice, it has been shown that it's a lot more difficult. And the reason why it's so difficult is not that we don't know what pieces of DNA to put in, is that we do not succeed sufficiently and at a high rate in getting these pieces of DNA in the right cells. But we have learned how to do it from nature. What is a viral infection? It's a virus that sticks to the cells, that enters the cells, and that uses the machinery of the cells to multiply itself. Now you take this virus, you cut out the pieces that are dangerous, so that it will still stick and be engulfed but not develop in the cell. And then you add to this some other tools that the virus then can use to cut out the bad DNA, stick in, splice in the good DNA. This is a mechanism that is used now to do gene therapy using viruses.
The ability to tamper with our genes has obvious applications. We can change DNA to prevent or cure hereditary diseases. We can alter the DNA of donor organs that are to be used for transplants so that the body of the recipient won't reject them. The organ doesn't even need to come from a human being. It could perfectly well be that of an animal.
Pigs would be a good supply of kidneys or other organs to transplant in humans. But because of the difference between the two species, the pig kidney or the pig liver will be rejected by the human. So if we can humanize the pig kidney by putting in some human DNA, which will make the cells look a little bit more human, so that they are not rejected by the person immediately, then there's a better chance that you'll have a take. And this is tried to humanize animal tissues, and it's becoming a big industry because we need more organs.
I think increasingly we're going to start realizing that this body is not sacred. The way we are is not some kind of God-given plan. It's really a pure random accident. We take two sets of genes and we shuffle them and something comes out. Sometimes it's a wonderful product, sometimes it has a hole in the heart, sometimes it has psychosis or tendencies towards extreme anger, has addictive problems, can't concentrate, all kinds of defects. To say, oh, that's normal, that's sacred, that's good, to me is rather absurd. It's random. There's not a plan there that we're thwarting. So genetic engineering seems to me one of the most moral things we can do.
A single species is defined by the isolation of our genetics, reproductive isolation. But when you begin to take genes from different species to mix together all of the genetics that is available among all animals, and also to design new alterations to the genetics, well, reproductive isolation really doesn't have much meaning anymore. And so you can imagine all sorts of forms and that will evolve in the future.
In the future, we will be able to sculpt our bodies like living sculpture. Our bodies could be beautiful electronic designs that shimmer prismatically in the light, in the morning light. It could change forms. It could become a piece of marble on one hand and then totally mutate into some fluid type of luminescent, snake-like quality. After all, the body is an extension of fashion.
You can rearrange the human body and try to make humans fly, even though humans are very heavy. And some mammals fly, like bats fly, but they're much lighter. But it's an intriguing question because it brings up the issue of not just trying to take an injured human and returning them to normal, but taking a human and making them superhuman, making them go beyond.
Our future is not to try and hold back genetic engineering, but to try and use it in a way that best serves us. If our children can be more intelligent and healthier and live longer lives through altering our genetics, why would we not want to do it? I mean, imagine if other children could live for 2 centuries, and if you could only live for 80 years because your parents believed that it was improper to tamper with human genetics. You would not be pleased with that decision. The same thing if your IQ were a normal IQ and all of your classmates were much, much brighter because there had been sort of some biological or genetic manipulation that was possible. You'd feel very angry about this.
Once we know exactly how our DNA code functions, we will be able to enhance our bodies. Human life will improve from one generation to the next as we control and accelerate natural evolution. But a rival to mankind is appearing on the horizon, a rival that is evolving much faster.
Are people becoming obsolete? A giant electronic brain has started cogitating at the University of Pennsylvania. It's made of vacuum tubes like your radio, and it can add up a column of figures a yard long in a second. It's the world's first electronic computer. Right now, it's solving mathematical problems for the U.S. Army, but who knows, someday a machine like this may check up on your income tax.
So imagine the human abilities as kind of a landscape with some peaks, which are the things we do well, and some valleys, which are the things we do really, really badly. There are things that we do extremely well, which are things that were important in our survival for most of our evolutionary history, things like moving around and socially interacting and perceiving the world. And there are things that we have only recently learned how to do, things like general reasoning. An extreme example is arithmetic, where we are very, very, very inefficient. Computers are different. They are universal machines. With an efficient program, they can do almost any one of these tasks equally well in some abstract informational sense. So the skill of computers can be likened to a water level that's uniform. The water level is rising. And it's rising at a rate that is about 10 million times faster than the rate at which we evolved those abilities. That and a number of other calculations lead me to believe that the highest peaks will be covered by this rising flood in less than 50 years. But once the level of computer competence has risen beyond the best human engineers, then there won't be any human engineers. There will be robotic or computer engineers.
We might one day duplicate man, his form, his body, his actions and reactions, carefully engineered for lifelike appearance.
Non-biological intelligence is growing exponentially. Biological intelligence isn't really growing at all. Or if it's growing at such a slow rate that it's not noticeable. Which is why non-biological intelligence ultimately will become dominant.
Yeah, right. So it's 101. 100, 010, or 001. Yeah, that's all.
Will computers ever become conscious beings? Computers calculate using zeros and ones. Therefore, many people, among them some scientists, believe that they will never become more than sophisticated calculation machines.
The great scientist, Professor Frankenstein, when his monster moved for the first time, without knowing it, he spoke of the absolute distinction between the artificial brain and the human brain when he said, "It's alive."
It's alive! It's alive! It's alive! It's alive!